How do you calculate angles on the Cartesian plane? Uh, in case you've been asking yourself how you do that, I'm going to quickly run you through how you can actually calculate angles on the Cartesian plane. So this is our XOY plane, also called the Cartesian plane. So you have to know how to calculate if an angle is there, if an angle is here or in here. You have to know all this, and within a few minutes that's what I'm going to quickly show you. This is very important for courses like physics under vectors, and also for mathematics under trigonometry. So to start with, if an angle is in here, you just know that all angles in the first quadrant, they are positive. So under vectors, if an angle is here being read from the positive x-axis, you just use it the same way it is. But what if it's at some other location? Yeah, so we're going to quickly look at some very quick scenarios. Okay, so let's get started. So for example, if we have an angle which is in here and also maybe an angle which is in here, how do you actually calculate such angles? So these, they are just relating to 90 degrees. So you know, when you reach this point, this is a 90-degree angle, this is 180, this is 270. So if you have an angle which is in here, how you calculate, I just explain it in this way. Imagine if we moved like this all the way up to this point, this would have been 90, but we have removed a certain portion here. We have removed this portion, meaning if we want to calculate an angle which is here, we just say 90 minus whatever angle, 90 minus theta. Yeah, so that is how you actually calculate angles. Let's say maybe here you have been given 40, so you just say 90 minus 40, that is the angle you will find there. Yeah, reading from the positive x-axis. And then what if we have an angle, let's say it is in here. So what if an angle is right in here? So under physics, when you want to calculate vectors, you don't use this angle which is in here. You should read from the positive x-axis. So you have to get the whole lot of this. So how you calculate if an angle is in here, you say 90 plus whatever angle is here, because this is 90 plus it's increasing. Yeah, so that's the first thing to know there. So an angle which is in here, you add to 90. If an angle is in there, you subtract from 90. Yeah, that's how you quickly read from the positive x-axis. Let's quickly proceed and look at another scenario. So let's put something in here and something in there. So so how do you read angles from the positive x-axis? So if it is here, you already know you add to 190. Here you subtract from 190. And then let's look at these two cases. So whenever you are given an angle which is here and you want to find the components, the resultant, you start from here till you touch the resultant vector. So at this point, you simply say 180 minus whatever angle is here. Yeah, so just subtract from 180. The reason is because if we reach here, this is 90. So if it reached this line, it would have been 180. But we're removing a certain portion. We're removing this portion, meaning in here, you always say 180 minus the angle which is there. In here, you add to 180. Whatever angle is here, you say 180 plus that angle. Yeah, so that's how you quickly do the thing. And we're almost done. What if we have an angle maybe somewhere there? So let's say an angle is in here, you subtract from 270, and then if it is in here, you add to 270, because this would be, here you've reached 180. If you reach to this point, this is 270, but we're subtracting a certain portion, so meaning this is 270 minus whatever angle, and then when we cross 270, meaning we add we add here. And then lastly, if the angle is in here, so at this point you just subtract from 360, because remember, if this was to make a complete circle from here going all the way, this is 360, but we're removing a certain portion. Yeah, so this is just something you can think of when you are calculating angles, especially for vectors, and also some knowledge in trigonometry. Yeah, so I just wanted to quickly take you through this.